Right then, so we've had a brief stint, an initial session on quadratic equations expressions. We learned some rudiments pertaining to roots and some properties. We also looked at the graph of y equal to fx equal to ax squared plus bx plus c, and some pertinent things that emerged. One, this always represented a parabola whose axis is parallel to the y-axis, number one. The axis of symmetry of this parabola would be x equal to minus b by 2a. 2, if a was positive, it's going to be an upward opening parabola. If a is negative, it's going to be a downward opening parabola. Now, based on some of these things that we have learned, let's examine some situations which could be handled with the learning that we have acquired. So here we have a quadratic expression y equal to ax squared plus bx plus c, and we want to populate the set of conditions that would cause both roots of the quadratic to be greater than a specified number k, a real number k. We want to populate all the conditions for which both roots of this quadratic would be larger than a specified number, real number k. So let me look at both situations, a greater than 0 and a less than 0. But irrespective of whether a is greater than 0 or a is less than 0, one thing is guaranteed. Since both roots are compared to a specified real number k, the roots must be real. Whether a is positive or a is negative, the roots of this quadratic must be real because the roots are being compared with a real number k. So a positive or negative, we must have discriminant greater than or equal to 0. Both roots could be equal also and could be larger than a real number k. So discriminant greater than or equal to 0, that is to say that b squared minus 4ac must be greater than or equal to 0, irrespective of whether a is positive or a is negative. Now, the additional set of conditions for a positive and a negative. So this would be common to whether a is positive or a is negative. Now, say a is positive. Say a is positive. The graph of this is going to be an upward opening parabola. And with both roots being real, alpha and beta, both roots are real, right? And a number k must be to the left of alpha, so that both roots are rendered larger than this real number k. Now, for sure, realize that this length is the value of the quadratic expression at x equal to k. This is the y for x equal to k. Y for x equal to k. That means f of k is this. One thing for sure, that this length is f of k and must be greater than 0. Must be greater than 0 if it is to the left of alpha for a positive. So the specific conditions, f of k must be greater than 0. That's one thing. But do you realize that this does not guarantee that k is to the left of alpha? Because if k was to the right of beta also, if k was to the right of beta as well, then also f of k would have been positive. So fk greater than 0 only tells me that k is either to the left of alpha or k is to the right of beta, where there is still a gray area. And we need to resolve this issue, right? To make sure and to conclusively write k to the left of alpha, an additional condition is required. Okay. Now, to get k to the left of alpha, see the difference between a k to the left of alpha and the k to the right of beta is its comparison with the axis of symmetry. This axis of symmetry is x equal to minus b by 2a is the axis of symmetry, right? So if k is to the left of alpha, k must be less than minus b by 2a, and that will be conclusive. That will make sure that k is not to the right of beta. So fk greater than 0 will cause k to be either to the left of alpha or k to the right of beta. This, along with b, that is k less than minus b by 2a, would do the job for us. K less than minus b by 2a would do the trick for us. k less than minus b by 2a would do the trick for us. That means fk greater than 0 would mean that k is either to the left of alpha or k is to the right of beta. That along with k less than minus b by 2a would cause k to be exclusively to the left of alpha. Yes or no? So this condition for sure, along with a and b together, 1 and a and b for a greater than 0 would cause both roots to be larger than a specific real number k. Now, suppose a is less than 0. Suppose a is less than 0. Of course, once again, discriminant will still be greater than or equal to 0 because roots are real anyways. A less than 0, y equal to fx versus x. A less than 0, it's going to be a downward opening parabola. It's going to be a downward opening parabola. Yes or no? This is alpha, this is beta, right? And k can be anywhere to the left of alpha. Say this is a real number, k, to the left of alpha, anywhere to the left of alpha. In this case, very clearly, this length represents what? The value of the quadratic expression at x equal to k is this. That means the value of fx at x equal to k is this y. So this is going to be f of k. This is going to be f of k. Very clearly, f of k has to be less than 0. So this is all for a less than 0. Fk must be less than 0. But this is not conclusive. Because k could have been lying to the right of beta, then also fk would be less than 0. So fk less than 0 only means that k is either to the left of alpha or to the right of beta. To make sure that it is to the left of alpha, we need to stipulate an additional condition. This is the axis of symmetry, which is x equal to minus b by 2a. This is the axis of symmetry. So if I say that k is to the left of the axis of symmetry, along with fk less than 0, would take care of all that we need. So k less than minus b by 2a is the conclusive remark. A and b, that is k less than minus b by 2a, would take care of things in this situation, right? So for a less than 0 or a greater than 0, this is a common condition. Discriminant greater than or equal to 0. And if a was less than 0, we should not only have fk less than 0, but k also to the left of minus b by 2a, etc. So 1 along with a and b would cause both roots to be less than a specified number k, provided a less than 0, right? Now let's look at another situation. Let's examine another situation. Can I wipe this off? Do you all understand this? Right? Okay. Now, say we have find the condition or conditions for which a real k lies between the roots of the quadratic. Lies between the roots of the quadratic. Now, this means again, since k lies between the roots, k is a real number, the roots are compared to this real number, that means the roots must be real. But in this case, roots cannot be equal. Therefore, discriminant cannot be equal to 0, because if roots were equal, then k couldn't be lying between the roots, right? K would be at best coincident with the roots, right? So for sure, whether a greater than 0 or a less than 0, this time we must have discriminant greater than 0 and not equal to 0, because roots cannot be equal, right? So that is b squared minus 4ac must be greater than 0. B squared minus 4ac must be greater than 0. Now, so whether a greater than 0 or a less than 0, this would be a common requirement. Discriminant greater than 0. Now, say for a greater than 0, the graph of this is going to be an upward opening parabola. Right? And this is how it is. Roots are real, alpha and beta, but not equal. They have to be distinct in this case, and therefore discriminant greater than 0. Now, k is a number here, sandwiched somewhere between the roots, and this is for a greater than 0. Very clearly, if k floats anywhere between alpha and beta, this length represents f of k. The value of the quadratic expression at x equal to k, y at x equal to k is f of k, which is this length. So f of k must be less than 0. Now, 1 along with a will cause things to fall in place, will cause k to lie between the roots of the quadratic. However, I have a point to suggest here. I have a small little remark here. If it's an upward opening parabola, and if you find that a portion of the parabola is below the x-axis, that means if f of k is less than 0, if there is a certain k for which the value of the quadratic is less than 0, it would mean that part of the parabola is below the axis, below the x-axis. It means part of the parabola is below the x-axis, and if part of the parabola is below the x-axis, then both roots of the parabola, both roots of the quadratic must be real, yes or no? So if it's an upward opening parabola, and f of k is found to be less than 0, then it would automatically mean that discriminant would have to be greater than 0, yes or no? And therefore f of k less than 0 for an upward opening parabola for a certain real number k would cause this condition to be redundant. This is not then required. F of k less than 0 would automatically imply this. This would be a subset of this condition, yes or no, right? So fk less than 0 would cause us to forget all about d greater than 0 when a is greater than 0, right? For an upward opening parabola, if it is found to be below the x-axis for some k, then it has to have real roots. Discriminant would automatically be greater than 0. So condition A is enough. 1 would not be required. Yes or no? Right? Similarly, for A less than 0, it's going to be a downward opening parabola. It's going to be a downward opening parabola, alpha, beta, and we want k to float between alpha and beta. K can float anywhere between alpha and beta, and this length is f of k. Value of the quadratic at x equal to k, that would be the value of y at x equal to k would be this length. Now, if k lies anywhere between alpha and beta, f of k must be positive. So f of k must be positive. It's a downward opening parabola with f of k positive. Now, a similar remark compared to the previous one. If f of k is greater than 0 for a downward opening parabola, that means if a downward opening parabola is found to be positive somewhere, then we can conclude readily. That means if f of k is found to be greater than 0 for a downward opening parabola for a certain real value of k, then the quadratic must necessarily have distinct real roots. So fk greater than 0 would automatically imply d greater than 0 and will be taken care of. Yes or no? Right? So fk greater than 0 would cause this condition to be redundant for a downward opening parabola. So the only requirement is fk greater than 0. So now, with this understanding of, how to deal with y equal to ax squared plus bx plus c geometrically using its parabolic interpretation and location of roots compared to the axis of symmetry, which is minus b by 2a, and comparing it with other real numbers k, we can obtain a myriad things a myriad magical things, and we can play around with it with ease and solve a number of problems, right? So this much for today. We are actually now pretty geared to solve problems. We can take on to some basic, simple to advanced to sophisticated problems, and we'll be there. However, a few more pertinent remarks in quadratic equations and expressions remain pending. Our next session would help us journey past those things. But then if we are through with all of this, then we are pretty well taken care of. Thank you so much for this time. We'll see you in the next class. Have fun and stay out of trouble. Bye-bye.